So we're back at this customer's house carrying out some EICRs on all 4 of his consumer units. Just a couple of points that were picked up on so far. So we saw this board last time when we came to the emergency call out that was a burnt out main switch. Just some things that make our job a little bit more difficult. You can see the cable in here is just very untidy. It's difficult to ascertain if the right CPC or earth is in the right slot on the main earthing terminal there, and just, you know, getting cables, conductors in and out of the terminals for testing just takes a little bit longer. There's obviously greater risk of a shock for us. You just don't know if a board this sort of untidy, you know, it's not a lot of care gone into that. It might be that some of these line conductors potentially have bits of insulation missing, you know, removed or scraped off maybe during installation by mistake. The problem that we're having with this, you know, bottom of the barrel budget range board as well, is that even when we torque these terminals on the RCBOs up to the required torque level, can you see the plastic is keeping the well, down the middle of the breaker is splitting apart. The screws on them are not the smoothest. You know, don't know how long they're going to last. There's not a lot of space in the top of the board there to get either your hands in or your insulated needle nose pliers to get that neutral down into the neutral terminal, which is a little bit deeper, so that's a bit of a faff. Anyway, whinge over. So a couple of things that we've picked up on so far. This is the chunky main supply from the garage consumer unit in there. So this is a 16mm squared piece of twin and earth. You can see there you've got your 16mm line and neutral. It's a 6mm earth though between here and the garage. You've then got going out to the house. See down there going into the floor. And out over to the house there is a 16mm 3-core armoured cable. Now we've yet to test the house, but there's 2 things the matter with that. One, I would presume that the minimum earth, I'm going to go into the literature on this one to confirm it, but off the top of my head, I mean, you know, this is quite an elegant setup in that we've got the garage consumer unit, and then the garage supplies the shed here, and then the shed supplies one of the consumer units in the house. I would have thought that we would need a 16mm earth back to the main incoming supply, which is in the garage. So for a certain run here, that's actually only a 6mm squared earth. Secondly, this is twin and earth cable. It's run through the fabric of this garage. There's an annex on the floor above. It's not RCD protected. Obviously, if we stick an RCD on the circuit, or an RCBO on the circuit supplying this shed and subsequently the house, if there's any sort of earth fault, you would then lose this shed, which is doing heat pumps, outside lighting, water heaters, hot tubs. This is the board in the house, and then half of the house as well. So we can't just stick an RCD on that circuit there, otherwise, you know, that's going to be massively inconvenient in the event of a fault, which obviously it was when we came to the initial fault, the burnt out main switch. So the other thing that we're going to probably have to do is rerun this in armoured cable. And I would say minimum, yeah, again, minimum 16mm, maybe more. So 16mm would give us sort of 80 amps here. Like I say, it's doing heat pumps, it's doing half a house. That'd probably be enough. So we'll probably go with that. But a better arrangement would maybe be to have switch fuse isolators at the main intake supply. So let's have a look at that now. Right, so here's the intake equipment. You see we've got an 80 amp main cutout fuse. Might just investigate as to why it's only 80 amps as to maybe 100 amps, although the tails against this board are the right size, so it's okay. You see here we've got utility consumer unit, so that's one of the consumer units in the house, and this big chunky 3-core armours. So it's 25mm cores going to that part of the house. That being said, because it's a circuit in the board, we're limited to an MCB size of 63 amps. Now this cable is capable of carrying, you know, there or thereabouts 100 amps. This is the boiler consumer unit that we were just looking at. Again, a 63 amp circuit fed from here in 16mm squared twin and earth. So it goes up here through the fabric of the building to supply the boiler consuming unit and subsequently the other consuming unit in the house. I would suggest that a better arrangement for this distribution would be to maybe have some switched fuse isolators here, so, sort of like this, but with, you know, a fuse carrier. And so rather than being limited to 63 amps for these distribution circuits, there's a bit more capacity there for future expansion. It would also minimise inconvenience in the event of a fault.